continue to stand by for today's conference call. The call will begin momentarily. Today's conference is being recorded. If you do have any objections, you may disconnect at this time. If you have any questions on today's conference, you may press star 1. Again, today's conference call is being recorded. Please continue to stand by. Thank you. Please continue to stand by for today's conference. Today's conference call is being recorded. If you have any objections, you may disconnect at this time. Your lines are in a listen-only mode until the question and answer session of today's conference. If you would like to ask a question, you may press star 1. Again, please continue to stand by. Thank you.
Good afternoon, and welcome to NASA's Lunar Delivery Readiness for the agency's Commercial Lunar Payload Services, or CLPS initiative, and Artemis campaign. I'm Antonia Jaramillo with NASA's Office of Communications. Carrying NASA science and technology demonstrations, Intuitive Machines' Athena lunar lander is scheduled to launch aboard a SpaceX Falcon 9 rocket no earlier than 7:16 p.m. Eastern Time tonight, February 26th, from Launch Complex 39A at the agency's Kennedy Space Center in Florida. This will be Intuitive Machines' second commercial launch to the moon's surface. Recently, teams with NASA and Intuitive Machines met to confirm that all NASA payloads flying aboard are go for launch. Here to talk with us about the NASA Science and the CLPS initiative are Nicky Fox, Associate Administrator for NASA Science Mission Directorate, Clayton Turner, Associate Administrator for NASA's Space Technology Mission Directorate, Trent Martin, Senior Vice President at Space Systems for Intuitive Machines, Bill Gerstenmaier, Vice President for Build and Flight Reliability at SpaceX, and Melody Lovin, Launch Weather Officer at Cape Canaveral Space Force Station's 45th Weather Squadron. After brief opening comments from each of our speakers, we will take your questions. You can enter star 1 on your phone to be entered in the question queue at any time. Your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. We ask that you please stick to one question and identify to whom it is directed. Shortly after we conclude, you can listen to a replay of this teleconference online. First, we'll hear from Nicky Fox. Nicky?
Thank you so much, Tony. It really is a very exciting day here as we get ready to go back to the moon. As Tony noted, this is the second launch for Intuitive Machines, and their lunar lander will be deployed. Will deploy NASA science and technology demonstrations to a part of the moon's south pole that humanity has never been to before. So that's really exciting, and it kind of feels like this mission is straight out of one of our favorite sci-fi movies. We're looking to show that we can find what resources already exist on the moon for a sustained human presence. And specifically, we're looking for water and other volatiles. And so as we are preparing to send our astronauts back to the lunar surface and to have a sustained presence there, and then eventually onto humanity's next frontier, which is Mars. Of course, before we do that, in order to get there, we need to find out what in situ resources are available on the lunar surface and enact the lessons learned from the Apollo era to ensure safety and also to advance our scientific discoveries and technological innovation. This is all part of NASA's Commercial Lunar Payload Services Initiative, or as we like to call it, CLPS, and we think of it as a one-stop, all-inclusive delivery service to the moon, where NASA is just one of many customers along for the ride. And American companies, as always, are at the forefront of innovation and discovery, all powered by NASA. The CLPS vendor in this case is Intuitive Machines, and they are responsible for payload integration and operations, launching from Earth and landing on the surface of the moon. We have already been successful in America's robotic return to the moon with the Intuitive One mission last year. And we're also launching today our Lunar Trailblazer orbiter as a rideshare. And so that's another really exciting thing for us as we get more science into space with one launch. So it's a 2-year science mission to map out water on the moon. NASA Science is also really excited to partner with our Space Technology Mission Directorate to bring back scientific data in ways never done before using cutting-edge technology on board IM-2's Athena lander. The moon is always full of possibilities, and this is the 4th flight of our CLPS initiative, and our payloads on board IM-2 will go where no spacecraft has gone before. We will be touching down 5 degrees from the moon's south pole, a lunar plateau called Moon's Mouton, which is about the size of Delaware and as tall as Mount McKinley. It is a scientifically strategic location that will return exciting data because of its origin story. It's 20,000 feet higher than any of the other neighboring features around the lunar south pole, and it's believed to be untouched by any of the lunar impacts for billions of years. And so we're zeroing in on this location for 2 reasons. It has a huge ring of craters which lie around its bases with cliff-like edges that descend into areas of permanent darkness. And its hilltop has smaller rocks and craters that are frequently blanketed in freezing, shifting shadows, and we hope that that's going to provide opportunities for extraordinary science in extraordinary places, and that's all made possible by this new revolutionary technology. CLPS landing sites are located on the near side, far side, and south pole regions of the moon, where we have high-value, high-priority investigations and exploration, and they are informed by the area's unique characteristics. So essentially, we design the science to go and do the best thing we can in these particular locations. To help future lunar landers determine the location more accurately for more efficient landings, NASA Science is sending, for the second time with a CLPS flight, a small, lightweight, inexpensive, yet very efficient laser retroreflective array, or LRA, on board IM-2. As we demonstrate that we can search for volatiles on the lunar surface, which may contain trapped water, ice, and particles from the early atmosphere of the moon and Earth, we're also exploring the different types of water available that exist across the moon's surface by mapping locations and studying the lunar water cycle with the Lunar Trailblazer mission. So it's really an ideal pairing. Lunar Trailblazer will peel away from the rocket as it is that it's sharing with IM-2 today, and will orbit the moon as part of NASA's Small Innovative Missions for Planetary Exploration, or SIMPLEX. Demonstrating that we can collect lunar volatiles using the science and tech demonstrations aboard IM-2 will not only help us better understand our solar system, but they will also be useful for our future astronauts as they look for in situ resources, including water, breathing air, and also for creating rocket fuel. Launching these two missions, IM-2 and Trailblazer, on a single rocket is no simple feat. It has required a great deal of collaboration between the teams to ensure their compatibility and their readiness for launch together. And the result today is a very efficient approach that doubles the science that we're excited to see lift off today. I'm really looking forward to the IM-2 mission launch, and I'm very excited to see the science that our tech demonstrations deliver as we prepare for humanity's return to the moon and the journey to Mars. So thank you so much to both of the teams at NASA and the teams Intuitive Machines and the teams at SpaceX for this really exciting trip to the moon. So go Falcon 9, go IM-2, go Lunar Trailblazer, and go NASA. And with that, I'll hand over to Clayton Turner.
All right, thank you, Nikki. I'm really happy to be here as we prepare for the Intuitive Machines' second mission to the moon through NASA's CLPS program. This mission is a great example of what NASA does best. We work across industries and agencies to reach a common goal of developing sustainable presence on the moon and paving the way for exploration on Mars. STMD is focused on supporting NASA's goal of long-term presence on the moon, with several technology demonstrations on this launch, including Prime 1, a drill and mass spectrometer, the IM hopper, a propulsive hopper that will allow us to explore the lunar surface, and Nokia's Lunar Surface Communications Network, which will be able to demonstrate communications in portable and long-distance ways. So those three technologies will open the door and demonstrate science we haven't done before, but as important, they will demonstrate how we're going to live and work on the lunar surface and prepare us to have humans on Mars going forward. In the beginning of this year, we have had over 20 lunar technologies on 3 separate demonstration flights being tested for the moon and eventually onto Mars. STMD is grateful to our partners across the agency and industry for the collaboration that this has brought us to this moment and a launch that we are about to do that will benefit all. So with that, go NASA, go IM, go Falcon, and let's live and work. And I'd show you a picture of my grandbaby who's going to live and work on the moon, but I can't show you on a telecon.
Thank you so much, Clayton. We'll now toss it over to Trent Martin. Trent?
Good afternoon. I'm Trent Martin, the Senior Vice President of Space Systems for Intuitive Machines. The IM Athena lunar lander is ready to go. We had a great wet dress rehearsal last night, filling both our liquid oxygen and liquid methane out at pad 39A. All of the Nova-C systems functioned as expected and are go for launch. All of our rideshare satellites are ready to go. Our ops teams in Houston and here at the Cape are sitting on console right now. We look forward to getting this complex mission off tonight and landing on the moon on March the 6th. Our 10-day surface mission will conclude on March the 16th. With the Prime 1 drill, the IM Micronova hopper, and the Nokia 4G LTE demonstration, we believe we're setting the stage for future Artemis missions. IM is go for launch tonight and ready to go change the world.
Thank you so much, Trent. We'll now toss it over to Bill.
On behalf of the SpaceX team, it's a real honor to be part of this mission. We've launched Intuitive Machines before, and it's a privilege to get a chance to do it again, along with the 3 rideshare payloads. I think when we look at these missions, we treat these missions extremely special. We know the value of the science. You heard it from Nikki, you heard it from Clayton, you've heard it from Trent. This is a pretty special mission, and we have to do our absolute best to make sure that the rocket is ready to go fly, the ground systems are ready to load the IM spacecraft properly with liquid oxygen and liquid methane, and we're really ready to go do this mission. So the teams have been reviewing everything. As Trent said, we did a dry run yesterday, or wet test, where we actually loaded the vehicle to make sure everything would operate correctly. That all went well. We learned a little bit from that. We'll change a little bit the timing that we do to load to help actually give a little better loading condition for them. We did see a small leak in our quick disconnect on the spacecraft, and you may see that during the launch tonight. That leak is very small. It's manageable, and it's fine to go fly with, so that'll be just during loading. You may see that. We're also checking. We found some problems with the MVAC nozzle. that we were preparing here in Hawthorne to get ready to go fly. We want to go double check that, but at this point we're go to launch. We don't see it as a constraint, but we'll keep looking at data. We'll keep double checking. We're going to make sure that the Falcon is really ready to support this inspiring mission. So again, I think we look forward to this mission. We especially like missions that are special, that demand a little extra work from us. If we're really going to be multiplanetary someday, we're going to have to do exciting and demanding missions like this, and the SpaceX Falcon team is ready to support.
Thank you so much, Bill. We'll now toss it to Melody.
All right, good afternoon, everyone. I'm going to cut straight to the chase. Weather looks excellent for tonight's attempt. The probability of violation is currently less than 5%, which translates to a greater than 95% go for weather tonight. I also wish this was a video interview, because I would show you this beautiful satellite imagery I'm looking at right now with a very low-topped clouds, really nothing to worry about tonight. So essentially just high pressure, keeping things great. So let's get it done tonight, all right? But if we do need to utilize the backup window for tomorrow, we do have a frontal boundary that's going to approach during the window. However, POV, it goes up a little bit, but not too bad. 20% probability of violation, which translates to an 80% go. That will be mainly for the thick cloud layers rule and the cumulus cloud rule, just because we'll moisten up a little bit in the mid-levels of the atmosphere. But otherwise, for tonight, temperature is expected to be 67 degrees with easterly winds around 10 miles per hour. So with that, I'll toss it back.
Thank you so much to all of our speakers. For awareness, we also have some additional subject matter experts on the line to help answer questions. We will now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered in the queue at any time, and you can enter *2 if you'd like to be removed. First up, we have Gina Sansari with ABC News.
Nicky, this question's for you. You've talked about the advantages of the CLPS program and how it can get things going, moving faster. How well have you seen this succeed with these past missions?
Hey, thanks so much for that question. We're really excited about our CLPS program. We started it in 2018. And it's really great to see it coming to fruition. We had 2 launches last year, 2 launches coming up, second one already this year. Looking forward to maybe some more CLPS launches towards the end of the year. Obviously, you have to reach out to the various CLPS providers themselves to give you their launch dates, but we're tracking more excitement in 25 and into 26. So we really do want to get on a regular cadence of about two launches a year, 2 selections of new missions a year, and really keep that momentum going. The ultimate goal of CLPS, of course, is to develop a sustainable lunar economy. And so to get these, as I noted in my remarks, to get this as a really regular sort of payload delivery service to the moon, where NASA is just one customer of many. And so for us, just the ability to get more NASA science onto the moon, looking forward, obviously thinking about the moon, then the moon lighting our way to Mars. So I think it's really going well. Really excited to see Intuitive Machines with their second lander, and of course excited as Firefly gets closer and closer to the moon as well. So really things going well with CLPS.
Thank you so much, Nikki. Next up, we have Issam Ahmed with the agency France Press.
Hello there. Thanks for taking my question. This is for Trent Martin. One of the concerns with the Nova C lander Odysseus was it was too top-heavy, which may have contributed to its tipping over. You mentioned in a previous call improvements to the laser altimeter cabling, but have you also done some weight distribution adjustments for Athena or some other things that might provide more stability when landing? Thank you.
That's an interesting question. We do not believe the lander is too top-heavy. You might watch a SpaceX launch. They land upright pretty regularly with something much taller than we're landing with the Nova C. The vehicle is fine. The CG is actually fairly low. The reason we toppled over was not because of a CG issue. It was simply because we were moving too fast downward when we weren't expected to be. And that caused the leg to break. When a leg breaks, you fall over. So I I don't think that's an accurate question.
Thank you so much for clarifying, Trent. Next up, we have Will Robinson-Smith with Spaceflight Now.
Hi, thanks so much for taking the time to talk with us. Question for Bill Gerstenmaier, if I may. You'd mentioned the second stage engine nozzle that you're doing some work on. Is that in any way connected to the scrubs that we've seen from the recent Starlink launch attempts over at Pad 40? And is there any crossover from work being done on that Falcon 9 that may be impacting the one over at 39A? Thanks.
Yeah, what we're doing is we're looking here in Hawthorne. We saw potentially a manufacturing defect that could have showed up in the nozzle. So then that kind of makes us question all the nozzles and make sure they're cleared. We've been through a lot of work last night and today, and we show that this is a pretty unique case, and it's going to be pretty much isolated to this one nozzle that we have here in Hawthorne. So it's going to clear the rest of the fleet. I think weather drove some of the other slips to the Starlink launches, and that's where we are. But again, what we're going to do is we're going to make sure our hardware is really ready to go fly. So whenever we discover something here that looks a little strange, we'll pause a little bit, take a look, dig into the data, and make sure we really have solid flight rationale, because these missions are too important for us to take lightly or to not really make sure we're really ready to go fly. So I think, we have schedule awareness. We're ready that we need to go launch when it's time to go launch, but we don't feel the pressure to launch unless the hardware is really ready to go fly.
Thank you, Bill. Next up, we have Mike Wall with Space.com.
Thank you all. This one's for Trent probably. I'd just like a little more information about the hopper on this mission, just in terms of what you expect it to do and kind of how does that technology kind of fold into Intuitive Machines' plans for kind of future lunar exploration. Thank you.
Thanks for the question. So hopper on this, the Micronova hopper is intended to launch off of the Nova C. We will do about 5 hops. We are testing the technology, proving that we can take a drone, if you will, on the surface of the moon and fly into places that rovers can't go. And we believe that is the future of this technology. We absolutely believe there's a place for rovers on the moon, things like the LTV that we're building for Artemis, but also there's a place for hoppers and technologies that allow you to go down into extreme environments where you can't drive your rover. And we've been talking with the scientists that are on our team, as well as other scientists throughout the world. We believe that once we demonstrate this technology, that those scientists will want to use this capability to go do hops down into pits or into lava tubes or into other permanently shadowed regions near the South Pole.
Thank you so much. Next up, we have Andrea Leinfelder with the Houston Chronicle.
Hi, this question is for Trent and also about the hopper. Why did Intuitive Machines add the PLWS neutron spectrometer to the Grace hopper? And what do you and your partners hope to learn on this first trip into a permanently shadowed crater? Thank you.
Thank you for the question. When we first bid into a tipping point, we were working on a hopper, and the intent was just to prove out the technology, prove that we could fly a hopper. And to the last question that came from that we just talked about, the scientists were eager to utilize this capability. So we both the German Space Agency as well as Pulley Space reached out to us with instruments that they wanted to put onto this hopper, even though we were a purely demonstration mission of the hopper itself. So we added the Pulley lunar water snooper specifically because it's a neutron spectrometer, and with that technology down in a permanently shadowed region, we should be able to see if there is potentially water. And so by developing that technology was developed under a separate contract for NASA JPL under an opportunity called Honey, I Shrunk the Payload. And so these PLWSs are extremely small, very lightweight, and so we were able to add it without a huge impact to both our hopper and our rover. We added a separate one onto the rover. And with that, we believe that we could get into a new market of data. Instead of having NASA or ESA or others tell us what instruments they want to fly. Instead, we could fly instruments and provide potential data sales to customers based on what they're looking for. If people are looking for water, why not add an instrument that can look for water?
Thank you so much, Trent. Next up, we have Lauren Grush with Bloomberg.
Hi, thank you. My question is for Gerst. I just was wondering if you can explain a bit more about how you are verifying that this nozzle on the Falcon 9 carrying IM-2 is not impacted by the nozzle problem you're seeing in Hawthorne, and at what point do you need to make this verification before you have to change the flight date? Thanks.
Yeah, we look at we actually have build paper for each piece of the material that goes into the nozzle, and we look at all that build paper. We look at the inspection results. We use all that data to ensure that the nozzle that we've got on the mission that we're ready to go fly is of a different caliber and a different design than the one that we saw the suspect condition in, or there was something unique about the one with the suspect condition. We've done all that now, so that's all clean. That paperwork all looks good. We're ready to go for the launch, but that doesn't mean we're going to stop looking. We're still going to probably do some more inspections here to understand this problem that we had here in Hawthorne. And if something comes across, we'll bring that up and let people know. But at this point, there's clear separation between what we're flying on the vehicle tonight and what we found here in Hawthorne. And that's evidenced by the detailed tracking we keep, the detailed material records we keep, the detailed information that shows there's clear separation between the two nozzles.
Thanks, Bill. Next up, we have Leo Enright with Irish TV.
A champion of his own extreme.
Leo, can you hear us? All right, I think we're having some trouble hearing you, Leo, if you want to try dialing in again. But in the meantime, it doesn't look like we have any other reporters in the queue. So if that's the case, we will wrap up today's call. Thank you to everyone who submitted questions, and thank you to today's briefers for taking the time to discuss NASA's CLPS initiative. As a reminder, Intuitive Machines' IM-2 mission is scheduled to launch aboard a SpaceX Falcon 9 rocket no earlier than 7:16 p.m. Eastern Time tonight, February 26th. Our live launch broadcast will start at 6:30 p.m. and will air on NASA Plus. Thanks again, and that will conclude our call.
Thank you. This concludes today's conference call. You may go ahead and disconnect at this time.